Welcome to today's session on multiple regression. So this is an extension of simple linear regression which you have seen earlier. So in simple linear regression, the regression equation is y equal to a plus bx. But in the case of multiple regression, the equation is y equal to a plus b1x plus b2x plus b2x2 plus etc. up to bn xn. Okay, so you take multiple parameters and you predict one parameter. So that is the concept of multiple regression. So in the case of simple linear regression, we use the function lm to find the value of the simple linear regression. In the case of multiple regression also we use the same function lm, but there is a difference in using the function. In the case of simple linear regression, we use two parameters, that is either miles per gallon against displacement or miles per gallon against horsepower or miles per gallon against weight. But in the case of multiple regression, we are going to use miles per gallon against a combination of the three variables, displacement plus horsepower plus weight. Okay, so that is the difference between simple linear regression and multiple regression. So here we are going to predict the value of miles per gallon based on the values of displacement, horsepower and weight. Okay, so all these parameters we are taking from the data empty cars. Okay, so we are going to first build the model and we are going to store the model in model 2. So the model 2 result are displayed here. Okay, so here what we can see is this value, that is 37.105505 is the value of the A in the equation. Okay, so and the next value minus 0.000937 is the value of B1 in the equation. Okay, so and the next value minus 0.031157 belongs to the B2 value of the equation. Okay, so the next value minus 3.80089 belongs to B3 value of the equation. So in our case, the equation is only having three parameters, that is B1, B2 and B3. Okay, so A is the default parameter. Okay, so to get the coefficient of the model, the values of A, we use the COEF function. Okay, so this is going to return the value of A, B1, B2 and B3. So B1, B2 and B3 are displayed separately. Okay, so in our case the equation is y equal to A plus B1 x1 plus B2 x2 plus B3 x3. There are only three parameters. Okay, so the value of y will be based on the value of A, B1, B2 and B3. Okay, the values of x1, x2, x3 are already known. Okay, so these are the constants. A, B1, B2 and B3 are the constants. The value of x1, x2 and x3 will be passed as a parameter while predicting using the model. Okay, so we are going to now predict using the model. For that we are going to first store the value of x1, x2 and x3, that is x1 is displacement, x2 is horsepower and x3 is weight. The values of x1, x2, x3 are 160, 110 and 2.620. Okay, so this is now stored in a data frame and it is stored in a new data variable. Okay, so now using this new data, I am going to predict using the model 2. The model 2 is nothing but the model for the multiple regression. So I am going to use this new data as the input for the multiple regression and I am going to predict using the predict function. So the predicted value will be stored in the mileage. So actually the miles per gallon value for the given displacement, horsepower and weight value is 23.57. Okay, so this is the prediction by the regression model. Okay, so for the given displacement 160, for the given horsepower 110, for the given weight 2.620, the predicted mileage per gallon for the car is 23.57003. Okay, the same thing can be plotted using the plot function. So here we are taking the MPG as one parameter and empty cars, displacement, horsepower and weight together as another parameter, and the color of the graph is said to be blue and the topic of the graph is said to be mileage per gallons and other factors multiple regression is the topic of the graph, and ab line will print the regression line. Okay, using the model LM. So the regression line will be printed using the abline function, and CEX function will set the font size or the size of the plotted graph, okay, plots in the graph, okay, and PCH is the shape of the plots in the graph, okay. So, and X label is given as other factors and Y label is given as miles per gallon, okay. So let me run this plot function and see how the result is coming. So let me zoom the plot. See, this is the plot for multiple regression. Um, so we have miles per gallon and other factors for the multiple regression. The other factors are listed in the x-axis and the miles per gallon is listed in the y-axis. So what this graph means is, as the value of displacement plus horsepower plus weight increases, the miles per gallon decreases. Okay, so when the value of displacement plus horsepower plus weight is less, the miles per gallon, the mileage is high. When it is when the value of displacement plus horsepower plus weight is high, the mileage is less. That is what the regression line is showing. Okay, so these blue colored ones are the data points given by the empty cast data set. Okay, so this is how the multiple regression works. So hope it is clear now how to understand multiple regression. It is in the form of a representation of an equation, so that we build the model using the LM function and we get the coefficients using the COEF functions, and we use the predict function to predict the model using the new set of data for which the value of mileage has to be predicted, and the same can be plotted in a scatter plot using the plot function, and using the abline function the regression line can be drawn. Okay, so hope it is clear, it was useful. Thanks for your patience listening.